Good afternoon, Algebra 2. We are working today on day 19 notes. And our topic is multiplying rational expressions. So we began with a couple of examples of multiplication properties. When you're multiplying rational expressions, or more commonly known as fraction problems, there is a pretty simple rule. That rule up here is basically saying everything in your numerators gets multiplied, so a times c, and everything in your denominators gets multiplied, b times d. Now, there's a quick review. When you're adding fractions, you have to have a common denominator. So in this case, 1/4 plus 2/4 would give us 3/4. Notice that we added the numerators but kept the denominator the same. However, when you're multiplying fractions, you multiply straight across the top and straight across the bottom. So in this case, we would have 1 times 2, which is 2, and 4 times 4, which is 16. That would simplify to 1/8. Simplifying being one of the key ideas for today's assignment. So let's begin with example 1. In example 1, we're given two rational expressions, or rational multiplication equation. Rational expression multiplication, there we go. So we have 2x plus 4 over 5x plus 15 times x plus 3 over x plus 2. What I'm going to do first is I'm going to rewrite both of these, or at least the first fraction. I'm going to simplify 2x plus 4. 2 and 4 can both be divided by 2. So I'll divide a 2 out from the front. 2x divided by 2 is just x. Positive 4 divided by 2 is positive 2. On the bottom, in the denominator, 5 and 15 can both be divided by 5. 5x divided by 5 leaves me with just x. And positive 15 divided by 5 leaves me with positive 3. On the right side, I just have x plus 3 on the top, and I have x plus 2 on the bottom. Now, if you want to make your life really complicated, you can FOIL all this out and get some really long equations. There's a reason why we did all the factoring previous to this assignment. So I'm going to basically just bulk everything in the numerator that's being multiplied. So the 2 times the x plus 2 times the x plus 3. So all the stuff from the numerators, I just put all together as one big multiplication problem. On the bottom, I'll do the same thing. I'll put everything, including whole numbers, into parentheses. X plus 3 and x plus 2. Now, the beauty of division is wherever you have common factors, you can go ahead and cross those things out. So I notice I have an x plus 2 on the top and 1 on the bottom, so I can cross those out. And I also have an x plus 3 on the top and on the bottom. So what remains? Well, on the top I have a 2, on the bottom I have a 5. So that's our solution then, 2 fifths. Everything else canceled out nice and neat, which is kind of the point of today's assignment. You have to remember how to do all the factoring methods we learned previously in order to be successful with this assignment. Let's go on to example 2. For the first fraction, I have x squared plus 2x minus 15. I'm going to go and just jump right into the factoring. I can't simplify it because there's only one x squared and 2 and 15 don't have any common factors. To get the x squared, I know it's x times x. To get the negative 15 and a positive 2 through addition, I know I'm going to have to multiply a positive 5 times a negative 3. Positive 5 times negative 3 gives me negative 15. Positive 5 plus negative 3 gives me positive 2. So those are my factors. On the bottom, I'm going to factor the perfect square. To get the x squared, it's x times x. Now, I need two numbers that multiply to give me a negative 9. But when I add them, they'll give me 0 x's. Because if you notice in this bottom part of the equation, there are no regular x's. Or in other words, there's 0 of them. So the rule for a perfect square is a positive and negative version of the square root of that number. So x plus 3 and x minus 3. That was from Algebra 1 last year. Multiplying on the right side, oops, I get my line going. 3x plus 9, both of those things can be divided by 3, so I'll factor out a 3. 3x divided by 3 is just x. Positive 9 divided by 3 is positive 3. On the bottom, I just have x plus 5. That can't be factored or simplified in any other way. So now I'll go ahead and just make one long fraction with all my numerator stuff. X plus 5, x minus 3, a regular 3, and x plus 3 again. On the bottom, I have x plus 3, I have x minus 3, and I have x plus 5. Whatever's common to the top and the bottom can be canceled out. So I have an x plus 5 here and an x plus 5 down here. I have an x minus 3 right here in the middle and one right underneath it. I have an x plus 3 over here on the right side and an x plus 3 down here on the denominator. So all I have remaining that didn't get canceled out was just this 3. So there's my answer then, positive 3. Moving on. Number 3 now. We'll begin the process again. I'll start with my left side fraction. 4x squared minus 4x. Not only can I factor out a 4 from both of them, I can actually factor out an x. So if I factor out a 4x from 4x squared, I'm left with just a single x. If I factor out a 4x from 4x, I'm left with a minus 1. Because negative 4x divided by positive 4x is negative 1. On the bottom, I need to find my factors. To get x squared, I know it's x times x. Two numbers that multiply to a negative 3, but add to a positive 2. Well, that would be, let's see. I really should have my notes prepared a little better. That would be positive 3 and negative 1. I don't know why I didn't see that one a little sooner. Times, on the right-hand side, I can't factor anything out from the top, so let's go ahead and just do the actual factorization of it. To get the x squared, I have x times x. What two numbers will multiply to a negative 6, but add to a positive 1? And those numbers would be positive 3 and negative 2. On the bottom, I just have a plain old 4x. I can't do anything with that. So now I'll rewrite my answer with all my numerator stuff on top. 4x, x minus 1, x plus 3, x minus 2. So those are all the factors thought in the numerator. In the denominator, I have x plus 3, x minus 1, and 4x. Canceling out all like terms to the numerator and denominator. 4x is our first to go. X minus 1, x minus 1s are good to go. X plus 3 and x plus 3 is good to go. So all I have left as an answer now is the singular x minus 2. There's my answer. So basically all we're doing is just factoring and simplifying by canceling out common terms to numerators and denominators. On the back now, so what happens when you get a division problem? Well, that's really easy to solve. And here's the big idea, I'll show you right now. So we have an example of 1/4 divided by 2/4. I legitimately learned a stupid rhyme when I was teaching middle school. And it went something like, when you're dividing fractions, just don't ask why. You flip the second fraction and you multiply. And that's actually the rule. You're going to flip your second fraction, or in other words, take the reciprocal. And then you do the same process we did in the front. 1 times 4 is 4. 4 times 2 is 8. 4 over 8 is 1/2. Or I could have said there's a 4 on top, a 4 on the bottom, and I'm still left with 1/2 over here. Same exact type of idea. So the only rule for dividing fractions is to flip the second one and then multiply. So I'll go ahead and do that first. I'm going to go ahead and I'll start off my first fraction. I'm going to begin with the factoring. The first fraction does not get changed. I can't divide by anything, so I just have to factor it. X times x is x squared. I need two numbers that multiply to a positive 10, but add to a negative 11. And that would be negative 10 times negative 1. On the bottom, it's another perfect square, like we had an example, I think it was example 2. Perfect square. To get the x squared, you have x times x. What numbers will multiply to give you a negative 1, but will add up to give you 0 x's? That would be positive 1 and negative 1. Basically the square root of 1 plus and minus. Now what I'm going to do is change the division to multiplication. And I'm going to flip this whole fraction upside down. So that means x plus 2 is now my numerator. That stays x plus 2, so that's no big deal. I'm going to take this 2x minus 20. What's common to 2 and 20? Well, that would be the number 2. 2x divided by 2 is just x, and negative 20 divided by 2 is negative 10. So now I have everything factored out, and let's go ahead and make one big answer with all my factors. So I have x minus 10 in my numerator, and then x minus 1 next to it, and being also multiplied by the x plus 2 that was at the very end. In my denominator, I have an x plus 1 times an x minus 1 times a 2 times an x minus 10. Let's take out all common terms. X minus 10 on the top and x minus 10 on the bottom cancel out to 1. X minus 1 divided by x minus 1 is also a 1. And then I'm just left with x plus 2 on top. So x plus 2 will be my numerator. There's nothing else to go with it. And on the bottom, I get 2 times x plus 1. I'll leave it like that. There's no need to expand it to make it longer. I have all the nice factor pieces here, and I'll stop there. You cannot simplify any further because this x and this x down here are not divisible by 2, so you can't do any further reduction or simplifying. That's your final answer. And then finally, we have number 5. It is a dirty one, I'm not gonna lie. So what I'm gonna do is I'm gonna work with just, for right now, the numerator. That in and of itself is a division problem. So what I need to do first is separate it. It's really 2x squared plus 7x plus 3 divided by 4x squared plus 15x plus 9 divided by this stuff here now. X squared plus 4x plus 3 over 3x plus 9. Great. So now I have to take my first fraction and I need to break it up. So here's what I'm going to do. I need to factor 2x squared plus 7x plus 3. I'm going to do that over here on the side in a different color. Remember, when you're factoring equations that have leading coefficients greater than 1, there's a bit of a process you have to do. 2 times 3. So now I have x squared plus 7x plus 6. Now I can get these factors. X times x is x squared. What two numbers multiply to give me a positive 6 and add to a positive 7? That'd be positive 6 and positive 1. Now I divide these answers by that original coefficient, the 2. And then I get x plus 6 divided by 2 is 3. However, I have x plus 1/2. Remember, this 2 slides in front of the 1. So I have 2x plus 1. So those are the factors for my very first fraction over here. Let me go back to my right color. I think it's the right color. So I have x plus 3 and 2x plus 1. Now I'm going to go ahead and do the same exact process to the bottom, to the denominator, to this fraction right here. So I have 4x squared plus 15x plus 9. I do the 4 times 9. It gives me x squared plus 15x plus 36. Factor this out. X times x is x squared. What numbers times themselves, or what numbers times themselves give me 36, but when I add, will give me a positive 15. Let's see, I think it's going to be not 6 and 6. I'm thinking, is it 9 and 4? Let me see where I did that work. To get the 15x, oh, it's going to be positive 3 and positive 12. There we go. I divide both these answers now by the 4 I had in the beginning. So I get over here now 4x plus 3, because remember that denominator switches up over here. And then I get x plus 3. So I can go ahead and go back and put these down here. 4x plus 3 and x plus 3. Cool. Now I have to do my multiplication of my second fraction. Remember, when you're dividing fractions, you flip the entire second one. So the 3x plus 9 is going to go on top. But look, I can already start factoring it now. What's common to 3x and to 9? The number 3. If I divide 3x by 3, I get just x. If I divide positive 9 by 3, I get positive 3. So I took care of that numerator. Now I need to factor this part to become my new denominator. To get the x squared, it's x times x. What two numbers multiply to give you a positive 3 and add to a positive 4? Well, that would be positive 3 times positive 1. Whew. So now I got all my factors. Let's lay them all out on the line, literally. So I have x plus 3 times 2x plus 1 times 3 times x plus 3. That's all found in my numerator. In the denominator, I have 4x plus 3, and then I have x plus 3, or times x plus 3, and then times x plus 3 again, and then times x plus 1. Let's cancel out any and all like terms. So I have x plus 3 here, and I have 1 here. I have another x plus 3 here, and another one here. And I think that's all I have so far that I can cancel out. So on the bottom, I'm going to have, on the top, I'm going to have 3 times 2x plus 1. We usually like to put the whole numbers first before we put the stuff, the factors in the equations separately or afterwards. And then I have 4x plus 3, correct, yeah, 4x plus 3 times x plus 1. And you cannot simplify any more from there. So that would be your final answer. That's a lot of work there, but that's how it breaks down. So that's your assignment for today. You're going to have to do day 20 assignment, which will be due by the end of class tomorrow. Hopefully this video helps you, and best of luck with your work. Good luck, guys.